All right, welcome everyone. So my talk today is about setting up your Flutter development environment now with Ultimate Unagi. There were some improvements since the last time I gave this talk, and we'll go through them. Today, it's mostly the most important part is about how do we attach external hardware, right? So our development board, our target board, and that's the latest improvements mainly. As you see, the slides are fresh out of the printer. Okay. I'm Jan-Simon Möller. I'm working with Vault on Automotive Grade Linux, dealing mostly with the CI/CD, the CIAD expert group, with keeping everything running. So the topics today is first an introduction, getting everyone on the same page, what we do, what's in there, and where to find what. And then I will show you the steps required. So AGL integrated Flutter based on Meta Flutter, which is maintained by Joel Winasket from TCNA. And we also did the new UI together with ICS in a very short time frame. So it shows that this is a powerful framework that you can use for your UI development. We integrate Meta Flutter, and Meta Flutter on GitHub hosts three main components. It's the Flutter engine, right? That's the core piece. Then there is the Meta Flutter layer, and then there's the workspace automation. This talk is using mainly the workspace automation, which helps you set your PC up, your development PC up, so you can easily work with that. We currently still base on ScarthGap. As Scott said, next week we will start the transition to Rhinos. So then we will also pick up the latest Meta Flutter by then. For now and in Unagi, everything is based on ScarthGap, and the same is true for Meta Flutter. We tend to upref Meta Flutter regularly. It's kind of every 2 months, every quarter, depending on when Joel releases an upref. The workspace automation was created to help set up teams to their development workspaces because there are quite a few moving parts. The Flutter embedder, the Dart SDK, and so on, and they want to have their proper setting in the tools like Visual Studio Code and so on. So this is the helper that basically installs all the prerequisites that does configure your settings. It's based on templates that are in the config folder, and we build upon that. Okay, so the example here is all exercised on a Ubuntu 22.04 host. And as I said, there are quite a few moving parts that have to fit together. It's not just the Meta Flutter, especially the SDKs need to match with what AGL ships, right? So we need to stay on par with the components here. And that's why the workspace helps here. We have a little chicken and egg problem, especially synchronizing Meta Flutter releases and AGL releases. So especially when there's an upref in Meta Flutter, right? So to match this up, we now have our own configuration templates where we can define the version that AGL is on. And that's what you see here. You see this Flutter workspace call. So we ship a workspace automation as part of the AGL tree. You find it in external workspace automation. And on top, as we pull this down directly from upstream, we used to deploy configs in upstream MetaFlutter, but that's a chicken egg problem because we need to release AGL to write the final config, right? Chicken egg. So we decoupled that. So that's why there is now a workspace configuration repo, and that can be pulled in with the remote flag in Flutter Workspace. This just adds the configuration file into the config folder essentially, and then you can enable a feature with the enable flag. So for example, there are 2 configs available right now for Unagi. That's the QEMU Unagi config and the Pi Unagi config, as we will see. So Flutter Workspace, once called, will do a lot. Install all the prerequisites, pull all the artifacts that's needed. So that will take a while. In the end, all the magic is hidden in kind of the config subfolders, and we set up the environment with setup env. So this contains all the magic to make kind of a Flutter environment available. It makes Visual Studio Code find the right path and environment. If you are developing against the QEMU, then you have to start up that QEMU VM. There's a script then available to start that. After that, go to your Flutter project and off we go. Now, let me walk through the basic cases here. So the most simple setup is you essentially just call Flutter run, and -d Linux means it's running natively on your machine, right? The good thing about this is this will just compile. It will run on your PC, native speed. You can debug it easily, but it has no specifics of the target environment, right? Example here, we start up the calculator and it will just run natively. Very straightforward, simple, native performance, but we are lacking target APIs, and we have to do another step to bring it into the target environment, right? So there's an integration burden afterwards. Now, here's the example with a Unagi-based QEMU image. The main difference is that we configured the workspace with the enable flag. We start up the QEMU in the background, and then Flutter run with -d AGL QEMU Unagi. You see the available devices, so -d means device. If you do Flutter doctor -v, and then you see multiple entries, and the third column is the device name. And in this case, we select then the QEMU image. Now this will compile your Flutter application for use within the Unagi image. It will then copy it into the running virtual machine. And you can essentially develop against a virtualized target environment. This example we see here, you can see well, it shifted by 90 degrees. We are running within QEMU. So this is now closer to the target environment. There is no IDE yet. The setup is quite straightforward and simple. As we have now the target environment available, this is closer and we don't need to do another integration step. It requires the emulated target VM. So this can be a bit slower, depending on if KVM is available or whatever host you have or run on. Now, one step further, we do the same, but now we can use a Visual Studio Code. This works in the same way, right? Source the setup environment, run the QEMU in the background, and then we switch to Visual Studio Code. The tricky piece is that you need to go to the run view and select the QEMU target there. Right, so you have to do a run configuration, select QEMU similar to the -D. We have to do the same. Once we have that, it will deploy to the QEMU. Magic. So this gives us full IDE support with all the bells and whistles that we have. Only drawback is that we have the QEMU emulation running. Well, which then also means we might not have all the hardware available. So next step, one step further, we go real hardware. So prerequisites. We need the hardware to be on the network. So the magic in the background relies on the board to be, well, pingable, right? To spell it out. The board needs to be connected somehow over network to your laptop. It does the steps in the background over SSH or SCP. So that needs to be available without password interaction. Of course, if you just remove the passwords, that's insecure. Now, Flutter has a custom device tool. Is that enough? It asks a couple of questions and would add the device. No, this is not enough. It would work for very simple devices, but not with our Flutter setup in MetaFlutter. There are examples, and you could edit it to get there. So especially the we need to stop the running home screen. We need to copy around more things. I made it in red here. Doesn't matter. So there is a lot of magic going on in the background to make these things happen. Now, okay, what can we do? We don't want to edit files, which is error prone. So what we can do is we can add a configuration specific to that board. Remember, we need the board to be pingable. So we have a configuration in our repo which assumes we have a Raspberry Pi available. We can add more boards likewise. And that board is basically flashed with a Unagi, AGL Unagi image, and running, connected to the network, and we can ping it. That's the prerequisite, and then we can do this. So we run the workspace, we enable the template, and in the end, if the board is reachable, we get this entry here. And you see in the second column here, this is the device name. You see device name Linux, that's what we had before. And the last one is then the one we would use. So the template has all the nitty-gritty details, and essentially you need the you could in principle get away with a Pi, configure it to use the USB gadget network, and then well, I added a HDMI KVM device to see the screen output. So, in summary, so to enable the local hardware, we need to create a template file. Example for the Pi is given here. We need to define either a host name or an IP address. Right? I went with a host name and edited my host file to include that. One thing that is not 100% working yet, and that's the debug connection of Visual Studio Code. I have a PR open upstream, and we are looking what port forward is missing to make that work. And of course, we can add more devices, so patches are welcome. Let me show you this in action. So what we see here, this is the Raspberry Pi, actually over there on the table, running the AGL image. And now we switch to the development system. You see Flutter Doctor -V. It will essentially ping the device, and if it's pingable, it's available here. And then we can call Flutter run -D, AGL Pi 5 Unagi. This will run through the Flutter build process, and in the end, it will execute a preparation step. In that step, it will shut down the original home screen, and in the next step, then start the configured application, the build application. Yeah, there we go. There's the application running. Okay. And the second one. The second one, same setup, but through Visual Studio Code. So I source the setup env. We see the Pi 5 device is available. After that, we can go to the example and start Visual Studio Code. Next, I will switch to the run configuration. And add a configuration for the device. There are no configurations yet. It asks if I want to add a Flutter configuration. And there is the Unagi device up there. So we'll choose that and start the build and debug session. You can actually see it in the background on the right side. That's the screen output as captured by the KVM device. All right, there we go. Yeah, so the one thing that's currently work in progress is the debug port connection. We do have a port forward in place, but we're probably missing one port. So we are working on that. All right. Any questions? All right. Thank you.